Hi, I'm Shane, and welcome to the Starwaves Explorer TV series. On today's program, we're going to be exploring sharks and coral reefs all throughout Asia, and we're going to check out some really cool new ocean technology. Now, this program is interactive with the internet, so go now to your computers, log on to starwaves.tv. Here's what's coming up next in the show.
The Starwaves team goes to a remote area in the Philippines to dive with an unusual shark seldom seen, an exciting encounter with the thresher shark. Could the cure for cancer and AIDS be hiding in the ocean? Scientists think so. Our expedition team travels to Malaysia to discover animals that are helping mankind.
Our planet is 3/4 water. Our bodies are 90% water, and we even spend the first 9 months of life floating in water. There's no wonder that the ocean is not nature's greatest medicine cabinet. Now, right here at the National University of Singapore, some really cool research is going on marine organisms and cures that are being developed from some of these marine creatures. This sea fan, which is common on coral reefs, is currently being studied here at NUS for some of its anti-tumor properties. Now, as our rainforests decrease, the ocean becomes probably one of our last real frontiers for the discovery of some of these new cancer and AIDS drugs. That's what makes the conserving of our marine environment so vitally important. Now, marine life sciences is definitely one of the coolest new areas of research. Next in the show, we're going to be traveling to a coral reef in Malaysia and check out some marine life and see how they're helping us fight some of the planet's deadliest diseases.
When researchers are looking for new compounds to study, a team is sent out to collect specimens from different ecosystems. For this bioprospecting expedition, oceanographer Professor Joe Valensic leads the Starwaves team to the island of Tioman in Malaysia.
Joe, we got some exciting things to explore down there. What's on the agenda?
Shane, we're going to look at a lot of animals that have potential therapeutic value. In other words, they have toxins which can be used for drugs from the sea. But also we'll be talking about some unusual fish. Now, fish, we said, have protection in a number of different ways. They have hard armor plate, they have spines connected with them, and they also have some toxins. Now, many of the pufferfish we know are poisonous to eat, but this fish is unique. It has a different protective mechanism.
He's up to something.
Which is?
With that, I think it is definitely time to get wet.
Let's go diving.
Let's go diving.
Okay, we're descending down onto the coral reef. We'll be in about 30 to 40 feet of water. Joe, we're going to do a little exploring, so you go right, I'll go left, and I'll see you a little bit later, okay? Okay. This exciting new field of marine life sciences is enabling us to share in the unlimited potential that the ocean has to help mankind. There's millions and millions of undiscovered life forms here in the ocean. So just think of the reef as one massive medicine cabinet full of all kinds of treasures. The wall that we have here is a living wall of corals. Most of the stuff that we're seeing, at least on the outside, is a soft coral, known as an octocoral. Octa meaning 8. It actually has 8 tiny tentacles in each one of its palms. The coral on the back, hard, stony corals. And in this case, we have a calcium carbonate exoskeleton. Each one of those round areas looking like about the size of a small circle is an individual animal. Walls like this, vertical walls, live corals on them,
are healthy because they have the right environmental conditions. And those conditions are primarily temperature. Coral cannot live below a certain temperature, and above a certain temperature, they also die. But within a very narrow range, these corals do very well.
Let's scan the chemistry of the ocean where Shane and Joe are diving and take a closer look at the conditions which the coral reef there are living in. Water temperature, 30 degrees. Salinity, 33 parts per thousand. Acid and oxygen levels, normal. Visibility, fair. All systems show a healthy reef environment for coral growth. As long as we humans don't injure this reef, such as snorkelers or divers breaking off coral for souvenirs, boat anchors crushing it, or oil spills, this beautiful reef should continue being a rich laboratory for life science research.
Scientists are just beginning to unravel the mysteries of some of the very, very complex toxins and poisons that are manufactured by reef animals. New painkillers, for example, the cone snail, which we'll be looking for today, is one of the reef creatures that is producing a form of poison that is helping develop a painkiller that is really helping improve the lives of many terminally ill patients.
Well, Shane, looks like on this beautiful reef down here, we found one of our first animals that we're looking at. This is a cone shell, aptly named because of its tapered bottom, almost like an ice cream cone. This is actually a mollusk, a soft-bodied animal closely related to the snails. It has a toxin, a poison harpoon on a nose called a proboscis. This shell is dead, so I'm not afraid to touch it. And this toxin, if extracted correctly, is up to 1,000 times more powerful than even morphine as a painkiller. So the little animal that you're seeing here, the cone shell, is one of man's best and most interesting ways for potential drugs from the sea.
We're down here visiting with our little friend, the clownfish, hiding amongst the stinging tentacles of the anemone. Hey, little guy. Or is it a little girl? I don't know. They don't have any problem getting a date on a Friday night because they have the ability to change sex from male to female. Anyway, let's go find Uncle Joe. He's out there exploring the reef somewhere. Let's see what kind of new treasures he's unearthed, okay? Let's go check it out.
One of the simplest animals is the sponge. Sponges have very interesting toxins connected with them. These toxins, in certain cases, have prevented or minimized tumors in laboratory animals. It's really amazing when you think about all the diversity of animals. When we look at all our soft corals, all of the anemones, what potential we have for science and medicine just here in the shallow oceans of the world.
We've had an incredible dive today, and we've learned so much about the exciting new area of marine life sciences. Professor Joe, thanks a lot.